Hi, it's repair time. Sorry about my voice, it's not good. So if it completely just vanishes during this and words don't come out, repair time. A simple repair, but it's one of these audiophile products. So audio foolery alert. And yeah, I'm sure it's just a high quality headphone DAC, digital analog converter. It's a Chord Hugo. Apparently this is a legacy product. And yes, look, it's got a wanky little window in there. You can see, that's some RGB LEDs. It's designed for, it's got a Wi-Fi module in it or something, and it hooks to your, streaming media server or whatever, and gives you super duper high quality headphone and line output. Right, so apparently it's got 2 rechargeable batteries in it, and I got this from a neighbour who wanted me to replace the batteries in it, because, yeah, it doesn't have a decent soldering iron to actually do it. So let's crack this thing open. Now, check this out. Apparently, these are just stupidly expensive. If you have to ask the price, the Hugo 2, this is the updated model. So technically the one we're looking at today is discontinued, but check this out. 4,500 Aussie bucks. We're on Brisbane Hi-Fi here. 4,500 Aussie bucks. It's ridiculous. Anyway, yeah, this Chord mob sell lots of high-end audio wankery. So the finest in audio wankery here, upscalers and phono stages and streamers and the DACs, and integrated amplifiers. Look at that. Oh, so wanky. Look. It's got an anti-vibration feed on it, so you don't get any microphonics and whatever. And it hooks up to your record player, right? Yes, so we've got the legacy Hugo product here. So yeah, like even secondhand, like this thing's going for like 1,100 bucks, right? Aussie, secondhand. It's just absolutely crazy, right? So anyway, yep, let's tear it down. So presumably we get these screws off, and I guess this lid pops off there. And it's really nicely made. We've got 4 rubber baby buggy bumpers. I like how they're indented into the case like that to stop slippage. Some sort of wanky light up window here, another one here, one on the bottom. You can't see it, but is that part of the Wi-Fi? Are they doing a cutout in the die cast for the... Yeah, you can't see that. Sorry, camera overexposure, but yeah, it's kind of like I can see the module in there. So let's take this apart, and it's made in the old Dart, of course. It's upside down, so all the electrons are going to fall out. So, hi to all my viewers in the old Dart. So, to want to be made in the old Dart for the money, I mean, this is just like thousands of pounds for one of these DAC things. But that's nothing if you're spending your $10,000 on your cryogenically frozen bidirectional snake oil speaker cable, and your, $5,000 for your power cable, and $2,000 for your wooden anti-vibration knobs for your pots. It's just, oh god. Anyway, yep. But I'm sure it sounds very good. I'm sure it's using it's probably got, I don't know, it got like a Burr Brown DAC in it or something? They usually use real high quality components. Like the new version has like an RTX 7 FPGA in it. So, it does all the processing and whatnot. But I didn't see on the marketing for the new one, like usually they scream at what brand DACs they use in it. I thought that would have been, I'm sure it's not, sure they wouldn't roll their own, would they? There we go, and we are in. A little bit of foam there that pokes through to that window. That's that window thing on the other side there, that little lens thing. Sorry, this won't be a full teardown. I'm not going to risk damaging my neighbour's doodad here, so I'm just going to do the business of replacing the battery here. You've got a Blue Giga Bluetooth module there. So I'm sure you can stream from your shoe phone and your whatnot. What's down on the bottom here? Nothing much doing there. It's just a microchip regulator there. you know, they claim linear regulators and everything else. Yeah, that's why they need 2 batteries in this, because they're doing the plus minus rail, so they don't need an inverter to get the extra rail. 78256, is that a memory? Is it? It's not a converter there, but it's not much to see here. It's a TI jobby, which is DK637. It's just an op amp of some description. Got a ferrite bead there. Nothing else exciting. Sorry, we've been mooned right on the bottom here. So yeah, let's get a multimeter on there and see what voltages we've got on the existing battery. You just said the batteries are dead, so I don't know in what capacity. Get it? Capacity? Ha! I'm here all week. Okay, let's measure that. Let's see what we get. Is anything on there at all? Oh yeah. Okay, 4 volts. So that's fully charged. So I don't know what the deal is. Yeah, they're both 4 volts. So not a problem. I don't know, but he did want the batteries changed, so maybe it's a capacity thing. The ESR in them could be bad, and because this is an old product. So anyway, he gave me these. The standard 18650. It's got a some battery protection in there. You can tell by the extra gap. It's a Cameron Sino. I don't know. Anyway, it is an 18650, and that's all it needs. So I assume that these things are going to be stuck. Oh no, no, they're not. No, I thought they might put some silicon in there or something, but nope. Look at that. Just comes straight out. No worries. All right, well, I will desolder that. 2200 milliamp hour, so we'll get a bit extra capacity in that. No worries. NX Energies. Yeah, so with 4 volts on them, it should have enough to work, but yeah, I don't know how to test this thing, so I don't know. Anyway, just wants the battery replaced. Oh, actually, I just turned a switch on the side and it is lighting up, so it does actually work. So yeah, so I'm sure he knows that. But yeah, so it must be a battery capacity thing, and I'm not going to bother testing the complete battery capacity there, but okay, so that's negative. That's oh yeah, there. I was going to say they should label that. They have. Don't know if you can see it. It's tiny. Jeez, could have made the silk screen a little bit bigger than that. I'm just saying. Let's get the other one out. There we go. So now, pro tip. Don't just cut the cables like that, because you will short them out, and that would be rather unpleasant. So if you're going to cut these, cut them one at a time. Thank you very much. So there we go. They are going to fit. Oh, yeah, they're just going to fit in there. If I fold that over and then like that, and bring them up over like that, I think I'll probably leave that lead length on them and then try and shove it down. I'm not going to try and cut it short or anything. So again, they've got tiny silk screen there, negative and positive. Wow, thanks a lot. Cable's formed a little bit, and it'll sit nicely in there like that. Let's guide them in place. There we go. There's the negative. Ah, I forgot to check the charge state of that battery there. 3.85, no worries. That will charge up. That will start it up, and then it can do its chargy thing. Here you go. One negative, one positive. Melted pretty easily, didn't it? Still got insulation on there. So that's not particularly high temperature insulation they got on those wires there, but next battery. Ooh, doesn't like the fit of that one. Seriously? Wow, just fits. Wow, that's pretty tight, isn't it? And if that case is sharp at all, that alloy case, you could actually short out to your battery case here, but the battery itself is going to, that's going to be negative. So that shouldn't be a problem, but you know, probably don't want that. Yeah, placement of this one gets a little bit tricky actually. So I'm not entirely pleased with the placement of that, but it's going to work. Like as in the actual design of it, not my placement of it. It's just the physical design of how this all. There's not much room left in there. That's all I'm saying. Not much room left for. Oh no, there we go. Just have to shuffle the battery down a bit more. Now there's more room. Okay, but still is a little bit tight. Just saying. And we'll measure that battery as well. Should have the same. Yeah, 3.85. That'll be enough to start up. Okay, make sure I don't short that out. Sorry, overexposure on the camera there. Bloody black solder mask. It's always a pain, but trust me, that's good. Turn that down a little bit. There you go. So you can see we have some nice filleties, a nice fillet of fish there. No worries. Yeah, when I turn the camera auto exposure, just like that black solder mask just like kills everything. It's just unbelievable. Switch over here somewhere. And now it's not doing anything. Well, I did something before. 3.85. 0. Why is that 0? Huh. Okay, we have a problem here. I'm reading 0.6 ohms between that pad. So yeah, the protection circuit of that kicked in. So why is that 0.6 ohms? Both directions. Short the probes out, 0.2, so we're talking about 0.4 ohms. What's going on? Why is that shorted? I don't get it. Our voltage over here is 3.5, so it's dropped down. Alright, something's going on. So let's actually give those some extra juice. As you can see on this channel here, using the power supply, 4.2 volts. So we're in. So that's the maximum compliant voltage. You don't necessarily want to go over that. And then we're constant current at 1 amp. 1 amp's good enough. I mean, that's not even 1C because these are 2600 milliamp hours. So we could probably charge it at a couple of amps if we wanted to. But that voltage is rising up. It was 4.08 or something before. So 4.10. So it's in constant current charging mode now. And then it'll switch to constant voltage, and we'll know we're pretty good to go. So okay, so that's very strange that we would get a short across that battery, like 0.6 ohms or something. So I've disconnected both of them, and I've plugged in the power pack, which is, it doesn't tell you on here, but it's a 12 volt half amp jobby. And if we switch it on, then we get, well, we get both of these LEDs lit up in there, not those RGB ones, but there's white ones like that. So that's interesting. Whoa, what's going on there? Is that switch dicky? I'm not sure if that switch is dicky because no, it seems to be doing that. That's all under software control, obviously. Now I switched it off, but that LED's staying on. So that's like a power in indicator, yet when you plug it back in, it doesn't come on. So this is doing some weird software wankery, right? I'm not sure what, but oh, my voice is getting bad. No, that's got to be coincidence. I don't think there's anything dicky in the switch. I think it's, yeah, doing some sort of software thing. We disconnect that. You can see that shorts out. Let's measure across here again, and we're getting nothing. There's no short, which is good. So it's not a short, it's something turned on, some I don't know, some MOSFET somewhere switched on, part of the charging circuitry. Don't know. Really weird. So I'm not sure what's going on there. So all I can do is put this solder. Maybe it's the order you have to solder them in. So maybe I'll solder this top one first this time, and then this one, and see what happens. So yeah, it's just strange. By the way, my neighbor said that, yeah, it's a capacity issue. So it still worked, but he'd only get like a couple of hours use out of it, and then it would die. So that's why those batteries still, these batteries here still work, but yeah, they're just dropped in capacity. And given that this is probably like I don't know, a decade-old model or something like that, that's not surprising. So anyway, so I'll solder that one in first, and then that one, maybe. I don't know, the order of it. I don't know. Anyway, I'll leave the switch off. And the interesting thing is, there is some sort of clicking noise inside this thing. So maybe that's like the charger. Maybe there's a loosey-goosey inductor in there or something. And definitely turns off when I got the switch in that position. So, which is over there, which is sort of towards the center. So that seems to be the off position. Don't label it. All right, so soldered back in, and looking at 4.01, I gave it a bit of a charge there. And yeah, it's good to go. So maybe, I can only assume that maybe I soldered these batteries in while I had the power on, and that because you install them, you can't solder them both at absolutely identical time. Maybe there's some interaction between them. So yeah, I'm not sure where I was measuring like 0.6 ohms between there. It's really interesting, but I'm not anymore. And it wasn't, no, there was no physical little DAG shorting across there or anything. I made sure of that. So it was something else. So it's really weird. Don't know. Right, so I have both of those soldered in now. And 3.93, and no, that's dropped. No, why is that dropped? See, once again, something weird has happened. I have not touched that, right? So, yeah, there's something weird when you solder those on. But it's like, right? So there's no short between there anymore. Wow, yeah, like that cell has been killed. What the heck? Well, it's got input. You can't kill the cell because it's got protection circuitry in it. But you saw that before, right? That was like 4 volts. And all I did was go and solder in this one, and the switch is in the off position. There's some weird interactive thing happening between these two cells. What the heck? The only thing I can do is maybe plug in the plug pack, see if it charges up, because that's just insane. What the heck? Okay, so plug it in. Okay, there is that that power LED has come on to indicate that. So it's obviously that's just a soft functional switch. There's there's some sort of thing bypassing that. There we go. Right? We're now 4.01 volts. How weird is that? That is very weird. You saw it, right? It was down to like 3 volts. So something was causing the protection circuitry in those batteries to kick in. This one here seems to have protection circuitry in it, because you can see that the cell physically ends there, and then they've got the something extra on the end of it. So that's got protection. Power on. Ta-da! Something's happening. Blue. Blue is good. Green is good. I believe that is, it flashes red if the batteries are low or whatever. So I think it's fixed. Yeah, I just didn't expect that level of drama, I guess, changing over batteries like this. But there seems to be some weird interactive thing happening. Obviously, they're going to have 2 separate charge circuits. And it's a soft thing, because this is not a hard power switch. Obviously, when you switch this off, the LED comes on, so it's it's not a physical on-off switch just for that. So it's, yeah, I don't know. That's weird. But I was definitely measuring 0.6 ohms between there, which would cause, it's a short. You shorten out the cell. So the output protection circuitry because the protection circuitry in these cells, they've got over voltage, over current, and low voltage protection as well. So it won't, so in theory, if you've got a decently designed protection circuit in there, with all those 3 features, you should not be able to kill the cell. But it'll certainly, switch it off. It'll switch off the output MOSFET will be in here, and it'll switch it off. And then the voltage that was feeding back was something from over here. It's weird. It's weird. So I'd love to see the circuit for this. If anyone's got the schematic for this, please leave it in. Please leave a link in the comments down below. But there you go. I do believe she is now back in action. Green. I'm going to assume green is good. And yeah, these LEDs in here are apparently, yeah, there's a blue, and you can actually see the 3 individual elements down in there. There you go. Maybe you can see it now. You can see the individual elements in there. There you go. It's not going to be color accurate. So it looks kind of, I just see red, green, and blue on. So it's supposed to be white, but yeah, doesn't really look that way. So I guess it does if you turn the gain up, but to my eye here, it just looks like I can see the 3 individual elements. Anyway, there you go. There is the Chord Hugo. Older model, the finest in audio wankery. I'm sure it has very good performance and everything, and the oversampling is great. Big ass FPGA in there to, do serious oversampling and stuff like that. And but yeah, I just don't see the value in these things. Like, I'm sure they work and sound fantastically. I'm just, as with a lot of these high-end audio products, I just don't see the value. Like, it seems designed to, apart from this weird whatever's happening with these dual batteries, apart from that, it does seem like a reasonable, a reasonably designed and built product. It looks, it's fairly solid, and, it's nice, and I'm sure it actually performs well. But, yeah, I'm just still not seeing the absolute value, but that is the market for these things. I mean, would you pay $4,000 for a DAC? The answer is there's a lot of audiophiles that will, right? And yeah, I'm sure it sounds absolutely fantastic, just whether or not you get the value out of it. But as with all things like this, if you pay $4,000 like this, which my neighbor didn't do, he bought it secondhand, so probably got it really cheap. But yeah, if you pay $4,000 for this thing, then you're gonna hear the difference. Trust me. Just like if you pay $10,000 for a couple of meters of speaker cable, you're gonna hear the difference. Just don't expect your friends to. Anyway, if you like that video, please give it a big thumbs up, and as always, discuss down below. Catch you next time. Oh, by the way, that sound, that buzzing sound that I heard, it's only when you plug in the AC adapter. Like, it's now running completely off battery power, and it's working fine, and there's absolutely nothing going on there, but I plug it in, and you can hear it. So, that is some inductor squeal. Not sure if you'll be able to pick that up on the mic, but it's there. And yeah, that's not uncommon for charging, switching converters, either charging or power supply or whatever, to have a little bit of inductory noise, but it's a physical noise. But it's not there when it's being powered from the batteries. And that's the whole point of this thing, is that you don't use it with the plug pack plugged in, because the whole point is that linear power supplies in there sound more better, of course, because you've got no switching components. They're powered directly from the low ESR of the battery and everything else. So, yeah, it's all hunky. Not that that's a problem, because they're not driving. Well, you can drive headphones with this thing. It does have a headphone driver, so you're driving a lowish impedance loan, but you're not driving tens or hundreds of watts or anything like that. So it's not particularly high power, but it probably will make a difference if you actually power this thing in. Maybe you can, I don't know, some switching components can come through, but the whole idea is that you charge it up during the day and then you disconnect it and you listen to it. And that's how my neighbor actually uses this thing. He uses it for a few hours per night, disconnected, powered from the batteries. So yeah, hopefully that is all good to go. Winner, winner, chicken dinner. But as I said, is this thing going to sound better than one that costs an order of magnitude less? I mean, it's still $400 for order of magnitude less cost for a DAC. So I don't know, you can build one. I could build one hell of a DAC for $400, let me tell you. So yeah, I don't know, but you know, people like the sound of certain things, and well, that's all there is to it.